complicated journey has a larger purpose. Once we've extracted what we need to feed the incredible machine and gotten our cellular engines humming, it's nothing short of astounding what we can do with them, thanks to amazing contraptions called muscle. The incredible human machine in action. Just about every body part, from our skin receptors to the balance center in our inner ears, help to make these amazing complexities of movement seem almost effortless, automatic even. But if we peer beneath our skin, we see that one tissue above all propels us into 1,000 different positions. From the soles of our feet to the tips of our fingers, some 650 muscles, about 40% of our body mass, power every move we make. As our day pushes on, these skeletal muscles lift us through it, usually without our thinking about it. Without them, we couldn't run, or blink, smile, or speak for that matter.
Hello?
Just muttering a single word.
Hello? Hello?
Hello.
Involves muscles in the face, lips, tongue, jaw, larynx, as many as 100 muscles. Many of the same muscles let us form a frown, turn them upside down, and all 34 muscles in the face let us deliver a kiss. Walking. A highly coordinated series of falls that we've taken for granted since we were toddlers. Requires no fewer than 200 skeletal muscles. Back muscles to keep you from falling forward. Abdominal muscles to keep you from falling back. It takes 40 or so muscles just to raise one leg and move it forward. Now add to that running, swimming, shooting, riding, and swashbuckling, and you get an inkling of how many different muscles are at work inside of Eli Bremer, top-seeded US Olympic pentathlete.
I think what I do is very normal, and someone will ask what a typical training day is, and I'll tell them, oh, I'll swim about 4 miles and run about 10 miles. You know, it's not that big of a deal. I mean, I think anybody could do it. And then I get this weird look like, you must be crazy.
So, what propels him? If we zoom in on one of these muscles in motion, and closer still at the hundreds of muscle fibers that run its length, we find two proteins, actin and myosin. And their actions couldn't be simpler. They link up, squeezing together like cogs on a wheel, and they relax, releasing their grip and going back to normal. That's it. If, during a fencing bout, Eli wants to strike his opponent, the actin and myosin in his triceps bind, while in his biceps they release. When he winds up for another blow, the opposite happens. Now his biceps bind and his triceps release. From this back and forth on all our skeletal muscles, we get our every motion. And at the US Olympic Committee's training center,